Welcome to Sundar's lecture. In this lecture, we are going to see concepts of complex power in AC circuits. Right? This is lecture number 47. So we know what is the expression for complex power, which means the apparent power. I am saying this as apparent power. See, S which is equal to P plus J Q. So this is uh, real power and this is the reactive power. So this is the complex power. We are calling it as complex power, or we can say it as apparent power. Right? Combination of real power and reactive power. For that, I am going to take a circuit with a resistive load. So this circuit is having 200 volt at an angle of 0 degree and the resistance of 10 ohms. And you see here an ammeter is connected to measure the power current of this particular circuit. Right? It will comes out to be 20 ohms. Anyhow, I will go for the problem now. So we need to find what is the current through this circuit. Right? Current through the circuit. For that, if you want to go for current, what is the formula to find current? I, which is equal to, which means I bar, which is equal to V bar by Z bar. Right? So what is the V here? We have 20 at an angle of 0 degree divided by what is Z here. Since we are calling it as impedance, but in this circuit it is purely resistive. There is no inductive reactance or capacitive reactance, right? So what we can write here? So this will be 10 plus J0, right? It is J0. There is no inductive and capacitive reactance anyway, which we can write like this, right? So 200 at an angle of 0 degree divided by 10 at an angle of 0 degree. If you convert this into polar form, you will get like this, right? 10 at an angle of 0 degree. So if you simplify this, you will get I will be is equal to 20 at an angle of 0 degree. So this is the absolute value, and this absolute value will be displayed in the ammeters. Wherever you go in the ammeters, only absolute value displayed. Right? So this is the final expression for the current I. And if you want to find what is the power, so if you are going for power, so maybe power, I will write it as power, which means I am going for apparent power. So S, which is equal to V bar into I bar. See, I need to put a star here. This star actually represents the complex conjugate of the particular phasor, which means I need to take complex conjugate of I here. I will tell you why we need to take the complex conjugate of I bit later. First, we need to find what is the current here. Anyway, I will tell you. So this value, which is equal to, what is V here? V, which we have 200 at an angle of 0 degree. So it will be 200 at an angle of 0 degree into, what is the current? It is 20 at an angle of 0 degree. So 20 at an angle of, if you need to take complex conjugate of this phasor, then you need to invert the angle sign, right? So it will be minus 20 degree or plus 20 degree, both are same. So I am not writing anything, maybe minus 20 degree. So if I simplify this one, I will get S, which is equal to 4000 at an angle of 0 degree. This is volt ampere. Right? What is this one now? Or if you want to write it in the rectangular form, it will be 4000 plus J0 volt ampere. So this is in polar form, this is in rectangular form. And what is this one? This is nothing but P plus J, and this is nothing but Q. Right? Here we don't have reactive power, we are having only the real power. So what is the real power value here? What is the real power? So real power, which is equal to 4000 watts. And what is reactive power? Reactive power, which is equal to which is equal to 0 volt ampere reactive. So this is the final answer. So this circuit draws 20 amperes of current. That is the point you have to note here, right? Now I am going to take another circuit. See, I have taken another circuit. This is circuit number 2. Maybe we will call it as circuit number 1, right? In this circuit, we are having the same voltage source, 200 at an angle of 0 degree, but R is equal to 6 ohms and L is equal to 8 ohms. I have written here directly the inductive reactance value, but it may be an inductive, maybe it is in Henry, then we need to convert that into inductive reactance. Anyhow, XL is equal to 8 ohms. Right? So we try to get the same things here. We need to find what is the current flowing this circuit and what is the power in this particular circuit. Right? For that, what we need to do, first we need to find what is the current in the circuit. So what is the formula for current? So I phasor will be is equal to V bar divided by Z bar. And if you want to get what is V here, that is 200 at an angle of 0 degree divided by what is the Z here? See, Z is equal to R plus J XL. So 6 plus J8. So it will be 6 plus J8. And if you convert this into polar form, you will get 200 at an angle of 0 degree divided by 20 at an angle of 53 degree. So this is the conversion of rectangular form to polar form, right? We have seen this one previously, and if you have any doubts, please verify my previous lectures. And if you simplify this expression, you will get again 20 at an angle of minus 53 degree amperes. Now you see, this is the absolute value of current, that is 20 amperes, right? Then what this ammeter will reach now? This ammeter will reach 20 amperes. This ammeter will reach 20 amperes. Try to understand, this ammeter is also reach 20 amperes and this ammeter is also reach 20 amperes, right? So if you want to find what is the complex power, maybe complex power or apparent power, we will call it as complex power, right? Power S, which is equal to V bar I bar star, right? I need to put star and I will tell you why I am using the star here. Maybe I will move this to that side so it will be easy to understand. So see here, we need to find what is V here. V is same, 200 at an angle of 0 degree. So 200 at an angle of 0 degree into what is I here now? It is 20 at an angle of, if you take complex conjugate of this 20 at an angle of 53 degree minus 53 degree, you will get, it will be plus 53 degree. That is the complex conjugate. And if you simplify this expression, what you will get, that is S, which is equal to 4000 amperes at an angle of 53 degree. 53 degree. And if you convert that into, this is the polar form, and if you convert this into rectangular form, then you will get S, which is equal to 2400 plus J of 3200 volt amperes. And what is P here now? What is real power? This is the P, this is P, and this is Q, right? This is the value of Q. And real power P will be real power P, which is equal to 2400 watts, and reactive power here, which is Q, that is equal to 3200 volt ampere reactive. See, both circuits draws the same current, that is 20 amperes, but this particular circuit has real power of only 2400 watts. But this circuit draws 4000 watts, that is fully real power. Why? This circuit don't have any inductive reactance or capacitive reactance, but this circuit has inductive reactance. Try to understand the apparent power that is absolute value of apparent power in both the cases are 4000 amperes, 4000 volt amperes, right? Both are same, both delivering the same volt amperes, but the absorption of power in the load differs in both circuits. So that is the difference between the complex power nature in the AC circuits. Why this is coming? See, this circuit utilizes the 100%, but this circuit does not utilize the 100%. It is not utilizing, right? Try to understand. We are the real power utilized power is only 2400 amperes upon 4000 volt amperes. See, here it is 4000 volt amperes. It is utilized totally as the real power, and this is why the power factor comes into picture if you are going for an industrial loads. Why? See, power factor plays a major role in industrial applications, since, see, I am giving 4000 volt amperes to a particular load. This load, maybe you take it as a consumer number one. This consumer is utilizing 100% of volt amperes, but this consumer is not utilizing the 100% of volt amperes, but both of them has to pay the same amount. But what this person, this particular consumer is doing, 2400 amperes has been utilized, but this 3200 VAR is again sent back to the supplier, and this power is actually waste power, not a waste power. Maybe there are so many applications of reactive power, but now in this point we will consider this as a waste of power. So if you want to calculate what is the power factor in this particular circuit, now maybe I will write here what is the power factor. See, this is the pi value, right? This is the pi value, and if you want to take what is the cos of 53 degree, you will get 0.602 value. So what this actually means, what is this 0.602? Which means this circuit is utilizing only the 60% of power that is given by the supplier. That is the whole meaning of this particular power factor. This is actually power factor, or this power factor can be also written as, see, power factor can be also written as real power, that means P by the apparent power. Yes, and what is the real power here? Real power here is 2400 amperes, 2400 watts, divided by what is the apparent power here, that is nothing but 4000. I'm just going for absolute values. And what is this one now? This is nothing but this is 0.602 upon 4000 volt amperes. We are using only 2400 watts here in this particular circuit. But if you are going for this circuit, what is the cos pi value? Maybe cos of, what is the degree here? It is 0 degree. So cos of 0 will give you what? It is 1, which means this particular circuit utilizing the whole apparent power in the load. Or you can go by like this. So if you are going for power factor will be is equal to P by what is this one? Yes, right? What is P here? 4000. And what is S here? That is also 4000. And you will get 1. So whole apparent power has been utilized in the resistor. That is the difference. So this circuit is not utilizing whole power. And if you are going for an industries, the supplier has restricted a power factor value of 0.8. It has to be 0.8. You have to utilize 80%, at least 80% of the given complex power. So that is the whole idea about real and reactive power. Right? So we will continue now to the next page. For see, I have taken I star. What is this star I have told you? This is complex conjugate. let us try to understand why we need to take complex conjugate to find the apparent power. So, importance of taking complex conjugate for current in apparent power. That is what we are going to see now. So, this is, we know this triangle, right? This is the power triangle. So, this is real power, this is reactive power, and this is nothing but the apparent power. And S is equal to Vi, which is nothing but it is apparent power. Va cos pi will be real power, and Va sin pi will be reactive power. We know this one already, right? So, or we can write it as S is equal to P plus JQ, or we can write it as S will be is equal to VI at an angle of pi, right? VI at an angle of pi. We can write like this. Anyhow, see now what we will do. Let us consider in general. What I am going to do, I am going to take V, which is equal to V at an angle of alpha. Maybe in so many cases this alpha will be 0 degree, right? We know that one already. Maybe I will be is equal to I at an angle of pi. I am going to take like this, maybe, right? So now what we will do, we will go for the phasor diagram. Maybe I will take a reference phasor. Maybe see, this is the reference phasor. This is the reference phasor. I am considering this to be reference phasor, and you see I have V at an angle of alpha, right? V at an angle of alpha, so I am going for V. So this is V, maybe. So this is the value of V. And what is this one now? This one. Maybe I will write this alpha afterwards because it looks clumsy now. So this I at an angle of pi. So you try to understand if this is this I lacks the V by some angle, and we can easily say that is the inductive circuit. Let us consider this as to be inductive circuit. It will be also applicable to the capacitive circuits. This complex conjugate concept, right? So now what we will do, this angle pi, we will go for that one. So I am just going to maybe take a new color. So this, it is nothing but pi. So what I will do, this is the value of, so this angle, which is nothing but it is alpha, and this angle which is nothing but it is pi, right? And what is this angle now? What is this angle? Alpha minus pi. Alpha minus pi. We know these kind of things. We can draw like this. This is the phasor, I phasor. So now what we will do, we will go for the expression now. So apparent power, that R complex power, S will be is equal to V phasor into I phasor. I am not taking complex conjugate here to explain you. I am not taking the complex conjugate. If you are not taking complex conjugate, on what is the V here? V, which is nothing but it is V of alpha. So it is V at an angle of alpha into what is I here? I at an angle of pi. I at an angle of pi. Right? This is the value. And if you multiply these two, what you will get? See, if you are multiplying this one, what you will get? Right. 1 minute. So what is this angle? So from reference it is alpha, and from reference what is this angle? That is nothing but pi minus, and you need to change this. And from reference, you see what is the angle of V? It is alpha. And from reference, what is the angle of this I? That is nothing but alpha minus pi, right? So it will be alpha minus pi. And if you multiply these two, what you will get? Obviously, this is V into I at an angle of, see, you have to add these two angles, right? Add these two angles. If you add these two, alpha plus alpha, it will be 2 alpha minus pi. See what we are getting here. S, which is equal to VI at an angle of 2 alpha minus pi. We know that S should be VI at an angle of pi. it should not be 2 alpha minus pi. It is a wrong answer, right? You are getting some other value, some other angle value here. Maybe if you are going for yes, in the complex form, this will be Vi cos of 2 alpha minus pi plus j Vi sin of 2 alpha minus pi. This is not at all correct answer, right? We should not get an angle of 2 alpha minus pi, and that is a wrong answer. Now what we will do, maybe I will take a different color to explain you. Maybe I will take S, which is equal to V bar I bar star. This is now we have to take the complex conjugate, right? We need to take complex conjugate. So if you are going for this one, what is V here? V here, it will be V alpha, V at an angle of alpha. We will write like this into, I need to take complex conjugate of I. If I am taking complex conjugate of I we know that I at an angle of alpha minus pi, and we need to take the complex conjugate. So if I am taking complex conjugate I at an angle of, what happens to this angle? It will be inverted. So minus alpha plus pi. So what I am writing, it will be pi minus alpha. Pi minus alpha. We will get like this. So if you multiply this one, what you will get? This will be is equal to V into I at an angle. See, we need to add these two. So alpha plus pi minus pi. Sorry, alpha plus pi minus alpha. Alpha and alpha will be cancelled out. And what is the final value? It will be Vi pi at an angle of pi. See, that is what we are getting here. That is the correct answer, right? So if you are writing this one, S will be is equal to Vi cos of pi plus j Vi sin of pi, and S can be written as Vi at an angle of pi. Right? This is the real power, and this is the reactive power. See, if you are not taking complex conjugate, you are getting some other angle. But if you are taking complex conjugate, we are getting the perfect answers. And that is why we need to take complex conjugate to find the complex power or apparent power in an AC circuit, right? To understand this one, right? So what are the topics we have seen today? So we have taken two problems, two different circuits maybe, to understand the impact of real power and reactive power in the AC circuits, and what is the power factor exactly means, and why we are having a supplier is given restrictions to the industrial applications to get the power factor above 0.8, and while finding the apparent power or complex power in an AC circuits, we are taking complex conjugate for current phasors, and we have seen with an example why we need to take the complex conjugate for current phasors in the complex power. So you try to learn this one, and we will take up a numerical problem in the next class, so that we can get a better insight towards the AC circuits and complex power. Complex power is a very important topic in AC circuits, and if you know basics of RLC circuit and the formulas for impedance, reactance, and real power, reactive power, then complex power, finding complex power in an AC circuit will be very easy. Will be very easy. That we will see in the next class with a numerical example. Thank you.